So everything that I've done up until today, including today, is examinable. But I leave space in the course to make sure that if my timings go wrong, I've got slack, and therefore these things are my slack. And what I plan to do in that is to talk about things that will come up, you will use next semester anyway in software engineering, and they're the kind of the things that are infuriating about the way we've done them now, which there are better ways of doing them, such that that will become common practice next semester. So I'm going to cover those in these slots, and the kind of stuff that I want to cover are vector connections, factory methods, stuff that's more commonplace when you do normal Java all the time. Okay? But they are not examinable material for this course. And that's why I don't want to do it today. Okay? Because we've already got this thing that's there. So I don't want to do too much of that now so that it conflicts against what we're doing. Okay? So my revision lecture is just covering the things that actually are going to be helpful for your coursework to make sure you don't make any of the silly mistakes that you've done already. And therefore, there are no tutorials next week. I'm in my office during those times if you need some help. Okay? So that's my plan for the rest of the course. Because the kind of Java that we've done in this course is really just scratching the surface of what's possible in Java, and so I want to provide the stepping stone for next semester at the end of my course to allow that to take place. Okay? This morning, it's quite nice, so in final year you have to do a project. Okay? So I this morning examined the final year project, who's just started. He was doing an Android mobile phone app to control via Bluetooth an Arduino board that was connected via relays to his car so that he could operate opening and closing the doors with his car, and opening and closing the doors with his phone and the windows and all that kind of stuff. It was well cool. It's really nice. So it was a really very nice example of how to bring kind of Java, your Arduino project, and the mobile project all together in a final year project. It was really nice. And he's actually demonstrated it. He actually could, so he's connected, so he's got a little board and he's got a relay, and he's now connecting it to various bits of his car. It was an Android. It was fine. So next semester in my Android course, I will invite him to come along and give you a lecture which demonstrates all of the coding that he's done for each bit of his project, through each of the phases. It was very nice final year project today. And the kind of Java that he was using in the Android side were things that you will see in software engineering next semester. So he was using singleton pattern, observer patterns, various listeners, and various handlers and services and so on. So it was really very nice. So that's what we're moving to with the Java that we're learning. So that's my plan. Okay? So and again, I'll communicate that plan when the new skins on Sunday. So let me finish where I was with exceptions and things from last lecture. So this is what you saw. Oh, maybe not. Yes, again. Oh, it would be helpful if I put it in. We're getting to the end of term. Let's see. More hopeful this time. So this is what you saw yesterday, and the class of exceptions that you definitely want to avoid are the red ones, and the ones that you actively throw as part of your code are sitting on that side over there. Okay? So, in file handling, when you do the file reader and the buffered reader and all those kinds of things, you have to actively write some try-catch to surround those things because the exceptions that were being thrown were checked. So if they're checked, you as the coder have to deal with them. If you are saying file reader new blah blah blah, then that code throws an exception, which is one of those green ones, and you have to deal with it. Okay? But the exceptions that I want you to throw when you're testing for the validity of parameters are unchecked exceptions. So, in the tutorials, if we had something which said public method A, I missed that one void. Let's just avoid that. Method A throws illegal argument exception and something here, and I've got some if then else clause here, and the if says throw new illegal argument exception. Blah, some comments. Okay. If this is the signature to the method, and if this is an unchecked exception, we saw in the tutorial that we did that if it's unchecked, you are not forced, when I'm writing code which says something like object dot method A in some other class or some other bit of code, I'm not forced to wrap that in a try-catch because the throw is an unchecked exception. However, if I used exception or IO exception or any of the ones that come from the checked class, then when I wrote this, it would force me to write a try-catch around the code. Okay? So your question, the thing that came up in the lab yesterday was, why do I stick the try-catch on the calling side? Why don't I just write the try-catch here instead? Okay? And the file handling one doesn't deal with the problem itself in its code. It passes the responsibility to the one that's made the call. So exceptions are things that you throw so that you pass the responsibility of the problem to the person who's caused it. I'm aware that in my lab sheet yesterday that there was one example where I dealt with the exception myself as a try-catch in here. That's not very typical. What's more typical is that if the problem arises in the method that you're writing, you don't deal with the problem in your own code, you just raise the problem so that the caller deals with it. That's the idea. Okay, and that's exactly what's happening with the file handling. When you do file reader blah 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 equals new, that code says there may be a problem. Your responsibility is to deal with the problem if it arises, and that's exactly what's happening here. Okay. So, if you're raising an exception, then you should always raise the one that's lowest down the subclasses. So you should never raise a runtime exception. You should always raise a more specific one down in the subclass. Okay. If you're going to write your own, then you're always going to extend the exception class. So your code is always going to provide checked exceptions, which is why I never recommend that you write your own exceptions unless you really, really have to. Use the ones that are provided if you can, because there are plenty in the runtime classes that you've already got. So, you write your own, then the way you would do them is extending the exceptions class. And we saw in the lab yesterday how to do that. But what I'm more interested in is how to deal with the exceptions that are raised. So let's go and look at those. So if you've got an unchecked exception and you throw it, you don't have to deal with it. Okay? But that's not to say that you shouldn't deal with it. You can choose. So, if I've got something that's throwing an illegal argument, and then I want to catch it, I put the name of the exception in there, and then I decide what to do. So the code in here, so the exception goes in here, the name of it, and the code to deal with it goes in there. Okay? So, if we want to, we could have a piece of code that had, say, a parameter here which took in an integer value and a string name. Okay, so in that bit there. And I could say, if my value is less than 0, throw an illegal argument, because it's a value that you've given me, but it's not the right one, therefore throw me an illegal argument. If the name is null, throw a new null pointer exception. I can differentiate between those two by throwing different ones. And as I have said in my Surrey Learn discussion board, I'm a bit sloppy with my exceptions. I tend to throw a legal argument for most things. Okay? But you should be a bit more picky than me in general. But there's no reason why you can't then have two catches in that way. Now Java 1.7 allows you to catch multiple exceptions in the same catch statement. Okay? So my slides are not 1.7. 1.7 allows me to list the exceptions in here, in more than one. Okay? So if you want to do that, that's absolutely fine, and I'm happy for that to happen. Okay? So you can now just list them all in one line. So, it's really important that you keep a nice message for what's going wrong. And normally, you must pass the code to, you can pass the exception to the calling method. But what happens if I want to be able to have a private method that throws an exception? This is not a public method that I called, it's a private method, and now I've thrown an exception. So I've normally, private methods are those that I use in the class to make the rest of my code look nice. So a public method in a class calls a private method because it's neater. Okay? But what happens if the actual private method throws something like that? Then that's where your try-catch can come into play in your own code. Instead of passing the try-catch responsibility to the caller, that's where it becomes more important in your own code. Okay. So, in the class diagrams that I've provided, I haven't included the throw information in the signature. You are not obliged to do that. It's good practice to do so if you want to, but you don't have to. The exam does not make them explicit in the signature. And therefore, all of the exceptions that I would expect you to call as a consequence of something going wrong would be the unchecked ones, because there is no file handling in the exam. So, what do I want to do? I want to be able to throw my exception if the argument isn't correct. And that's a slide that we saw yesterday. Okay? So, in the calling code, I would then expect to see something which says, call me a canine object, and I know that the canine object is incorrect. Therefore, the catch statement will execute, and I can print out that catch statement, and then I can carry on running that code. Okay. So, in that case, the try block was executed, but whilst executing the try block, the exception was thrown. Therefore, the catch block executed, and after the catch block, I carried on running my code. Okay? Because at no point there did I print the stack trace in order to terminate my code. So, in the try-catch block that's given by default through Java, you get the print stack trace, which is what causes the code to terminate. Okay? And that's what you don't want to happen if you want to recover from the catch. So, in terms of the catch method, the print stack is what you normally see. And that's useful because it tells you exactly where it's formed, and then that'll fail. But when we've also seen these try-catch blocks, we've also seen the finally block. So they come in triples: try, catch, and finally. So we need to understand when the finally code gets executed. So the try is the good behavior. The catch gets executed when an exception is raised as a consequence of the try block. So when does the finally thing get executed? The question is, not at all, always, as a consequence of the try, or as a consequence of the catch. And so there's options on when the finally should execute. So when is that going to happen? Well, the finally code is the block of code that should run always. So you've got try, catch, and finally. So the try is the good behavior code that you want. If something goes wrong in that, the catch code runs. But then you might want to have some code that always runs afterwards, which is what the finally block does. And that's why the streaming of files and the shutting of the streams in files always goes in the finally block. Because you always want that to happen even if something has gone wrong. So the analogy with finally is like the default block in Switch. If you forgot to put all the breaks in, the default block executes. So there's the same kind of concept that happens in the finally block. Okay. So, what do I want to do with finally? Finally always happens. Okay. So, I've got my canine object call, and 101 means that 101 says that the bark was too loud, therefore the exception was raised. So the illegal argument message is actually going to be running, and then the finally block will always run, and then it will still run. But what happens happens if I've got something which says something like this. If I've got a, hang on, I'll show you this. I make a new pitch. I'm going to make a class, example class. And I'm going to have an integer. It's not very meaningful, but it'll do for now. Okay? If a is greater than, less than 0, or less than 9, let's throw an exception. Can't type. We'll have that, okay? Then I'm going to have a test class called example test. And let me just make the main method so I can create some quick objects. So we'll call that example E equals new example, and let me stick bits. Put that in. Okay? Let me just stick a get to in PA as well, just so that I've got something to play with. Okay. So I've created something, and hopefully now, if I run it with 9 or 10, all should be fine. So let's see. And then I'll run it with the exception. Okay, so that's okay. But now if I check it with 8, now hopefully we'll get a nice exception. Perfect. Okay? So the number's too small. But if I now do this, right. What? Oh. Am I not harnessing oh yeah. Our view met together. Right? So I'm going to try that without my binary at the moment, okay? So now it should say terrible naming conventions. Let's try. That's in the try catch. Oh, okay. That's because it's only a long, it's a not long. The scope of it is in that block. Okay? So now, if I run that, hopefully I've done the catch. Okay? So it never got to that point, it threw the exception and got to the catch. But if I now want to be able to run my binary bit, I'm just going to borrow that bit of code so I don't. it's going to do that anyway, okay, even though it threw the exception, because that's a bit of code that it wants to do. And so now, if I do it with a nice value, it will still get to that point. Okay? So it's going to run whether I run the exception or not, and therefore it gives me a well-structured place to be able to do that. So,
what's the difference between putting codes in a final block and then just leaving it outside of the try-catch statement?
in the without this bit, okay, if I'm running it with the good value, then I'm going to run that. If I'm going to run it with a bad value, then I'm going to also have this. But if I had my stack trace, then I'm hoping that it will actually stop what I want to do. Now, oh gosh, that's not what I was expecting. Bugger. How am I going to explain that? Let me have a think for a minute.
Right.
Oh no, that's not what I was expecting. Because the catch, I was expecting that to run, and I was then expecting that to stop. Ha! No, let me think about it whilst you try and answer the question. Let me think about that whilst we're dealing with this one. Go back to there. You answer that. On channel 23,
have you finished all the labs? What channel was it? 23? Is it number 3? Huh? Yeah.
Simulated polling. I know. Nothing I can teach you avoid that. Well, at least we're getting 100% project.
You have to put in the same parameters as a specific. So if it says stream A, then you have to put in the same nationality.
I have
Why should you use such a deep colour for question 2? It's the same thing, right? Yeah. Double answer.
One and two. She wants 100%, that's it.
She's just going to get 50-50 at best.
Yeah.
It would be good if we can do the exam like this.
Okay, so a checked one expects you to deal with it with a try catch. Okay? And that's something that you have to add. Okay? So,
Oh, they should switch the
now
question.
this is what I thought when I wrote this slide. And this is still true, but what I'm absolutely puzzled about now is if I leave it out, I'm still doing that. Yeah, I don't know if it's because of that, but I need to experiment with it a bit. It could be, but I'm not convinced. I don't know. I'll have to have a go at a few bits of code. My thought process is not, that's not what I thought.
Number 3.
Okay, so the finally block, which I still need to nail, normally you execute it whether you've got your try or your catch, but I'm puzzled as to why my code still ran that when the finally wasn't there, especially after the catch was forgot. So I need to understand that better, and I need to be able to explain that better. I don't know how to explain that at the moment. So, in terms of where we're at, I think my smiley faces are getting bigger, by the way. So the important thing for your coursework is to not do a try-catch in the tests. The purpose of a method of throwing an exception in the code is to recognise that the exception is being thrown. We are not writing enough code to handle the exceptions when they're thrown. All I care about is that your code is robust to recognise that an error has been thrown. Okay? So in the test, all I want you to do is accept that an error has been done. In the coursework, if you want to change it to actually deal with null point of exception in the case of a null check, then please do so. My test in the test rider has an illegal argument exception in it. Okay? And if you want to be able to check the messages explicitly, then in the lab for testing we dealt with rules, and rules are something that I do want you to be aware of and use them in the current coursework if possible, to enable you to test the actual message that's coming out if you are throwing more than one exception for validation checking of parameters. Okay? So if you've got this on the right hand side where you're throwing two different ones, I want you to be able to tell me which message is being thrown. And that's something I will use in the coursework and in the exam. So I would like to have that in both pieces of work. Okay? So the file handling from coursework 2 is where the most examples for checked comes from, because in the current coursework I'm also not expecting you to produce your own exceptions unless you want to. The built-in ones are sufficient for what we want to be able to achieve. Okay? So, whilst I'm going to give you an exercise, I shall then think about how to figure out my final comments. Okay? So, what I want to be able to do is to have a piece of code that we had. This was in coursework 2, and we were trying to see where the exceptions were being called and how to deal with the catching of them. So, in the case of the file handling, here we didn't want to deal with it internally, we simply threw them again to the caller. But in the code that we typically wrote, we dealt with them inside our code, and that's okay. So this was just passing the buck some more. Whereas this one is actually dealing with it internally inside the code, because these guys, the new buffered reader, was actually throwing these errors themselves. Okay? So you can nest try catches inside code.
For a provided method that Eclipse provides you with, or Java provides you with, like open a new buffered reader.
Yes.
Is there a way to know what exceptions that might throw?
Yes, in the API of buffered reader, in the signature of the class, it tells you, and in the methods of the class, it tells you what exceptions will be thrown. And you have access to the API in the exam, therefore you will know what exceptions the APIs will throw. So you're not having to guess what to put in the catches. If you go and look at the API of buffered reader, it will tell you that these are the ones that are going to be thrown. Okay? What about this one?
Is it because false is in the last line? Is on the second line? It's fine.
Yeah, it's fine.
Maybe, possibly. Okay. So, there are a couple of copies of this in the library. And these are really good examples of things which are interesting in Java. So, the class was a class, and then class indecisive, and the code inside it, I'll write the code out. Just put that down there, so you can see the code there. So there was a decision and the try block had try, return true, and finally return false. Okay. And the explanation it gives is that hang on, where did I put it? Number 36. So what we spoke about just now was that the finally block should always run. And the interesting thing that you will look at next semester is we'll start to look at the specifications of Java to work out all the details of how these language syntaxes were defined. So if the try block completes abruptly, then that should run. But the code should try, so in here it says, when both the try and the finally block code complete abruptly, the reason for the abrupt completion is the try block is discarded. And then it goes on to say, in this program, the abrupt completion caused by the return statement in the try block is discarded because the try finally statement completes abruptly because the return statement is the finally block. That simply put, the program tries to return true, but finally it returns false. But in terms of what you want is that, in terms of, it kind of goes on to say, discarding the reason for the abrupt is never what you want. So, the finally block should complete normally, barring any unchecked exception. Never exit a finally block with a return break, and never allow a check to propagate out. So you should never jump out of the finally block with a return. So, the construct for finally requires the completion of the code to be happened properly. And because it can't complete the code properly, it doesn't execute the return. So the return was attempted to be done in the try block, but because there's a finally block there as well, it will try to do that. But the finally block needs to finish completing its code normally. Therefore, the finally block can't also execute. Therefore, none of the return statements are executed. So, what does that leave us with? If you've got a method which needs to have return values and try and catch, it's really difficult to know what to do to deal with the return values. And this is why in a method which has return statements, instead of dealing with the tries and the catches, this is why people use the throw in the signature to move dealing with the try and catch to somewhere else, so that in the main block of the method you only have the good code, so that you never get into this mess of knowing whether your method is going to return a value or not. So, the key from this example is that I've got a method, want to put some value back to you, a boolean, right? But the code that I want to run could potentially throw an error, which is why I wanted to have some kind of random try catch in there. But that could make it more confusing when you're trying to combine them with your return statements. If you're ending up with that kind of code, move the responsibility of dealing with the exception to the signature by putting the throw in there, so that your method code can say, if blah blah blah, then return, else throw new blah. And then you don't have to worry about whether your return will get executed or not, because you're not having to deal with the exception in the method. Okay, that's the main principle from this particular example. So, what have we got? We've got 3 classes of unchecked that we want. Illegal, null, and arithmetic. And that's the important thing that we want to deal with. Okay? So, how am I going to deal with the rest of what you've spoken about so far? What we're going to do is we're going to look at, I go back here. I'm going to look at what I've covered, and you're going to have a bash at your understanding so that it feeds into your coursework. Okay? So what are we trying to do in this course? Well, we're trying to get you to understand the basics of Java and the basics of OO. That's what we wanted to achieve. Okay? And we wanted to understand where Java fits with testing, and we've only dealt with unit testing. That's the overall goal of the course. The goal is not to deal with patterns, the goal was not to deal with design in order to make good design, but it was to start to trigger your enthusiasm about how do I model bits of Java. Okay? How do I model bits of code, and how do I represent data structures? That was what we were intended to do. You should be able to write syntactically correct code and deal with OO stuff. You should be able to define your own class data types, and you should be able to use all of the common control statements in Java. That's the aim. And the improvement in dealing with loops this time was significant compared to the formative piece of work. Okay? The important thing is that you do need to understand how to deal with mapping UML diagrams into code. We're not expecting you to write the UML diagrams at the moment. We've had some workshops to get you to think about them, but the goal was to be able to interpret them. So, of the 7 exam papers that are on SuriLearn, there are 7 sets of UML diagrams, and they are the basis for the exams. And they've got some inheritance structures in them, etc. Okay? So, in the UML diagram, you end up with field and the name, the fields, and then the methods. And I think the thing that most of you need to make sure that you nail properly is to organize the methods in the same order as the class diagram. In the exam, I have, and in the coursework generally, I have included the getters explicitly in the class diagram. Normally this is not common practice. Sometimes people leave out the getters, the simple accessors for fields from the diagrams themselves. Constructors are never included on the diagram. Okay? That's where you have to figure out how to create those things. But this is what we're trying to do with all of the coursework and all of the example exams that you need to do. So, what have we done? We've started off with empty design classes. We've looked at fields, enums, and constants. So, one of the important things I want you to be able to cover is the following. And in your current coursework, I really need you to be able to deal with finally in a liberal way. So, if an object has a field which is supposed to be fixed upon creation and not changed after that, it has to be declared as final. It's no two ways about it. make your intent absolutely clear by using final as much as you can if you want to fix the state of your field. So, the key thing is that if I got a field, say, private A, and I want that to be fixed upon making the object and not changed afterwards, I can then say final integer A. Now, I can either do it upon declaration, or if I've got a class A and in my constructor I can set A to be 10. Is that good or bad? I've got a constructor that's setting it to 10 and I've set it to 0 here. Bad. So I can declare it and initialize it in two separate places, but once I've initialized it here, I can't reinitialize it there. And that's very important. So I need you to do that because if I've got a class that's got something that doesn't want to change, at no point should I provide a method to set A, which takes in an integer and then sets this A to A. I should not provide a method to do that. That's a crazy thing to do if I want my object to be immutable. Strings are immutable by default, but if you want your object to be immutable, then make your fields immutable. And we will discuss next week that you can go one step further and make the class immutable. But for your coursework, you need to use these annotations for fields as much as you can in a liberal way. So, when you're using them as constants, that's something that you need to be able to do. If they're constants that are shared between all objects, you definitely need to make them static. That's important. You need constructors, and we'll work out whether you need a parameterized or a default constructor. And these are all the things that we've done on the course. Okay? So, all the fields are typically private, except that if you're making a subclass and you want access to a superclass's variable, then you can make it protected. And there's nothing wrong with doing that because we are doing that in the current coursework. The question about where you want to initialize your lists, do you want to do that upon declaration or in the constructor? I don't care, but you need to do it in one of them. And if you do it in the constructor, then the declaration should be null. So these things, if they're not correct in your new coursework, that's not good, because I'll be checking for these things in the coursework itself. Okay. You don't have to provide a parameter for each field. In your current coursework, if you pass in the team and the rider as an empty list or a list as a parameter to the championship class, why are you doing that? A championship should start with an empty set of people because you have an API that allows you to add riders. If you had an API which didn't have an add rider, then passing a list would make sense. But if you're passing a list and offering the add rider, that seems not sensible in the scenario that we're looking at.